Today we're starting Chapter 14, Trig Applications. And so we're on page 1 of our Chapter 14 notes packet. The first section is Law of Cosines. The length of one side of a triangle can be expressed in terms of the other two sides and the measure of the included angle. The law of cosines is this. In any triangle A, B, and C, A, B, and C, the vertices of the triangle, and then lowercase a is the side opposite angle A, lowercase b is the side opposite angle B, and lowercase c is the side opposite angle C. The law of cosine says this. Lowercase a squared is equal to lowercase b squared plus lowercase c squared minus twice their product, 2 times b times c, times the cosine of angle A. In other words, side A squared is equal to the sum of the square of the other two sides minus twice the product of those two sides and the cosine of the angle. Now, the side and the angle here at the end, the beginning and the end there, all right, they must match. So the outsides must match. So this is the side opposite the angle, and this is the angle. So if you wanted to find the side opposite angle B, lowercase b or b squared, that side squared, we'd equal the sum of the sides of the other, the sum of the squares of the other two sides minus the twice the product of those two sides and the cosine of angle B. Side C squared would equal a squared plus b squared minus 2 times a times b times the cosine of angle C. So Formula 1 is given to us on the reference sheet. All right, this is given to you on the reference sheet. So you do not need to memorize it. But you do need to know how and when to apply it. Again, but really, with practice, you will have it memorized and not need to refer to the reference sheet. These are the steps we'll take. First, to apply the law of cosines, all three sides of a triangle and an angle must be represented. You start with the length of the side opposite the angle you are given or trying to find. So you say the side opposite the angle squared equals the sum of the squares of the other two sides minus twice their product and the cosine of the angle. Substitute into the formula and solve. Please solve your equation for your variable before touching your calculator. So you really want to have a calculator available when you're watching this video. Okay, so here you have example 1. Find the nearest tenth the length of side PQ of triangle PQR. All right, well, let's stop there before we go any further. Draw a diagram. There's triangle PQR, right? The vertices of the triangle are named by capital letters, okay? So opposite angle P would be lowercase p. Opposite angle Q is lowercase q, and opposite angle R is lowercase r. We want to find the length of segment PQ. Well, segment PQ is the side opposite angle R. So we're finding lowercase r. If lowercase p is 63, and lowercase q is 107, and the measure of angle R is 42, find the side opposite angle R. Okay, so this is what we have. We have sides of 63, 107. We're finding R, and we have an angle. So all three sides are represented. Okay, we're trying to find side represented by R. So we're using law of cosines. And law of cosines would say that we start with the side opposite the angle that we have in this case. So that side squared, so R squared, is equal to the sum of the squares of the other two sides. So it's going to equal 63 squared plus 107 squared minus twice the product of those two sides, minus 2 times 63 times 107, and the cosine of the angle, meaning the cosine of angle R, cosine of 42 degrees. Okay? Again, I like to use this. Right? Law of cosine says you're starting with the side opposite the angle you have. So that side squared equals the sum of the squares of the other two sides minus twice their product and the cosine of the angle. Okay, now, well, R squared equals this. What does R equal? R would equal the square root of this whole thing. So 63 squared plus 107 squared minus 2 times 63 times 107 times the cosine of 42. And we're talking about the length of a triangle, so we're not looking at the negative value of it, just the positive. So that's why we have R equals simply the square root. Okay, the variable is by itself. Go to the calculator and key the whole thing in. Make sure our angle measure there is in degrees, so make sure that your calculator is in degree mode. Okay, so I'm keying in the square root of 63 squared plus 107 squared minus 2 times 63 times 107 times the cosine of 42 degrees. Round to the nearest tenth, 73.5. Again, the key is going to be plugging into the equation properly and then solving for your variable and then plugging into the calculator. So the next example, we have in triangle ABC below, AB is 8, it's already marked for us. BC is 13, it's already marked. Angle B is 110. We want to find the length of AC to nearest tenth. Okay. Well, what lowercase letter would represent AC? Well, that's the side opposite angle B, so it would be lowercase b. So we're trying to find this side. All three sides are represented. We start with the side B. Right? Applying law of cosine says that that side opposite the angle, so b squared, is equal to the sum of the squares of the other two sides, is equal to 8 squared plus 13 squared, minus twice the product of those two sides, the 8 and the 13, and the cosine of the angle, cosine 110 degrees. So b is equal to the square root of this. Go to the calculator and key in square root of 8 squared plus 13 squared minus 2 times 8 times 13 times the cosine of 110. Nearest tenth, 17.4. Again, you would need to show substitution into the formula. That's this work here. And then I want you to have the variable by itself, the next line, and then go to the calculator. Okay, now does this make sense? Is this reasonable? 17.4? Well, yes, because it's definitely, this is the largest angle of the triangle, 110 degrees. So that needs to be the longest side. Next, An isosceles triangle has legs of length 15 inches and base angles that measure 36 degrees each. Okay, so I need a diagram. My isosceles triangles always look like this. The legs are 15 inches, so those are the two congruent sides, and the base angles are 36 degrees each. Okay, so this is my base. These are my legs, in case you need a refresher from geometry. So our base angles are down here, and they are 36 degrees each. We want to find the length of the base to the nearest tenth of an inch. Okay, I'm going to call this x then. All right, I'm finding the base. I'm going to call it x. All right, so we have all three of our sides represented. Now, if we're finding this side x, we need to know the angle that's across from it. So what is this angle here? Well, the three angles of any triangle add up to 180. So if we add these two, 36 and 36 is 72. And then subtract that from 180, that'll give us our what's called our vertex angle, 108. All right, so this is a 108-degree angle up here. All right, my triangle is not representative of that, but that's okay. We're just working with the numerical values we have here. Okay, so we want to find this side. So that side squared is equal to the sum of the squares of the other two sides, 15 squared plus 15 squared, minus twice the product of those two sides, minus 2 times 15 times 15, times the cosine of angle of 108 degrees, cosine 108. So x equals the square root of this whole thing. Go to the calculator. Square root of 15 squared plus 15 squared minus 2 times 15 times 15 times cosine 108. To the nearest tenth of an inch, 24.3 inches. Another word problem. A parallelogram has sides of lengths 10 and 14 and one angle equal to 110 degrees. Find the length of the shorter diagonal to the nearest tenth. Okay, well I've got the diagram for a parallelogram here. And before we mark it up, just let's take a look at this. All right, this is a shorter side, this is a longer side. So I'll write 10 here and 14 here. And as far as our angles go, all right, this looks to be acute. So let's put our 110 up here. Now, what do you remember about consecutive angles of a parallelogram? All right, we know that opposite angles are equal in a parallelogram. Consecutive angles are supplementary. Another recall from geometry. Consecutive angles of a parallelogram are supplementary. So we have to remember some geometry. So if this is 110, its supplement 180 minus 110. This would be 70 degrees. Now, why do I need to know that? Well, it asks us for the length of the shorter diagonal. Okay, the shorter diagonal. Well, this would be my longer diagonal. I don't want to draw that one, right? Because that would be longer because it would be opposite. If I split this up into a triangle, okay, that's going to be opposite the greater angle. So this is my shorter diagonal. And that's what we're trying to find, this shorter diagonal. So I'm going to label this X. So we have our three sides represented, and we have the angle opposite the side which we're trying to find. So this is using law of cosines. So law of cosines says that the side opposite the angle of 70 degrees, x squared, is going to equal the sum of the squares of the other two sides minus twice the product of those two sides and the cosine of the angle. And hopefully you should be saying this along with me, or kind of whispering it under your breath. So x is equal to the square root of this whole thing. And go to the calculator. We're rounding to the nearest tenth. Second. Okay. 10 squared plus 14 squared minus 2 times 10 times 14 times the cosine of the 70-degree angle. To the nearest tenth, 14.2. Now, what if we want to find an angle measure? All right, using law of cosines to find angle measures. The angle is going to equal the cosine inverse of this. I'm not going to have you memorize that. All right, what I do is just substitute into law of cosines and get the angle by itself before you go to the calculator. If the sides of a triangle are 20, 22, and 25, find the nearest tenth of the degree, the largest angle. Okay, well, let's see, 20, 22, and 25. So this looks to be the shortest side. I'll put a 20 here. 20, I think this is the longest side, so I'll put 22 here, and then 25. The largest angle is opposite what? It's opposite the longest side, okay? So I'm going to call this L. Right? I'm going to call this angle L. We have all three sides of our triangle represented here, and we're finding angle L. So we start with the side opposite that. Plugging into law of cosines, we're going to say that 25 squared is equal to the sum of the squares of the other two sides, 20 squared plus 22 squared, minus twice their product, times the cosine of our angle. We don't go to our calculator until we have our variable by itself. All right? And stay with me for this. Okay? I want to get cosine of L by itself. Well, we have this addition, and then we have some subtraction and multiplication. We'll first undo the addition, meaning I'm subtracting 20 squared, subtracting 22 squared from both sides. So that leaves us with 25 squared minus 20 squared minus 22 squared is equal to negative 2 times 20 times 22 times cosine L. Doing some algebra here, not touching the calculator yet. Now this is all multiplication. What undoes multiplication is division. So we're dividing by 2, 20, and 22. Sorry, dividing by negative 2, 20, and 22. So we have here that the cosine of L is equal to this fraction. 25 squared minus 20 squared minus 22 squared, all divided by negative 2 times 20 times 22. Well, the cosine of L equals that. So that means that angle L equals the cosine inverse of that fraction. Now we go to the calculator as soon as I finish writing this. I'm sorry, I'm getting smaller and smaller here, so I'm running out of space. Ready? Calculator. looking for the angle measure, so we do second cos. See if I can get this both. All right. Alpha y, oops, nope, sorry, second cos, now alpha y equals, and 25 squared minus 20 squared minus 22 squared. Denominator, negative 2 times 20 times 22. To the nearest degree, no, sorry, nearest tenth of a degree, 72.9 degrees. 72.9 degrees. Okay. And again, with practice, all of that manipulation there is going to get simpler, much faster at it. Find the smallest angle. The smallest angle is opposite the shortest side. Right? It's opposite the shortest side. So opposite 20, I'm going to label this S. So we're trying to find angle S. So that means we start with the side that's opposite it, the 20. So law of cosine says that 20 squared is equal to the sum of the squares of the other two sides minus twice the product of those other two sides and the cosine of the angle, S. Okay, next we're going to bring these two things over to the other side. I'm not going to show that, right? So we're subtracting 22 squared and 25 squared from each side, and that's going to leave us with negative 2 times 22 times 25 times the cosine of angle S. Now this is all multiplication, so you're dividing by these three. So we have 20 squared minus 22 squared minus 25 squared divided by negative 2 times 22 times 25. This equals the cosine of S. So now finally to the calculator, I'm going to write it over here. So angle S is going to equal the cosine inverse of that fraction. And sometimes to save time, all right, since I have cosine already up there in my calculator, if I bring it up and just go in and change, let's see, my 20s and 25s, I think. So this has to be 25. You're not quite seeing it, but I'm getting there. And this is 20. So cosine inverse, 20 squared minus 25, or in the order here of the 25, 22, doesn't matter. Just the 20 needed to be first. Negative 2 times 25 times 22. Looks good. 49.9 degrees. 49.9. That's for angle S. And then lastly, for the third angle, well, let's take 180 minus the sum of the two that we found. So 180 minus 72.9 plus, this is in parentheses, 49.9. There you go. Close my parentheses. 57.2 degrees. And there we have all three angle measures, 72.9, 49.9, and 57.2. And this concludes our video for today. Thank you.